All right, let's start this presentation with a few review problems. First, solving equations. Solving equations isn't going to go away. So we're going to start this one by using the distributive property. So negative 5 times x is negative 5x. Negative 5 times 2 is a negative 10, so we're just going to write minus 10. And then we're going to just rewrite the other side. So now I have 10 minus negative 5x. I see I have x's on both sides, so I'm going to add 5x to both sides. This negative 5x plus 5x cancels out, and I'm left with 10 on this side. Negative 5x plus 5x cancels out. I'm left with negative 10. Negative 10 and 10 do not equal each other. So since there are no variables and the sides don't equal each other, can't happen, so we say that it's no solution. We have been working with, for the next example, the rate of change. The rate of change we can find in a variety of ways, and on a graph an easy way is just to look to see how far you have to go up and over to get to another point. So how far you have to go up and over. So I see we have to go up 30 and over 2, or up 60 and over 4, or I could even go up 60 and over 4 this way, or up 30 and over 2 here. So how far you go up compared to over. So in all cases, like 30 over 2, or 60 over 4, or 90 over 6, when we do that division, we end up getting 15 to 1. So our unit rate for this is 15 clothes for every one washing machine. So this presentation is going to focus on comparing proportional relationships. We have been looking at different types of proportional relationships on graphs, tables, and equations, and today we're going to compare them. All right, so for this first example, making comparisons, we're going to be looking at Weston and Jaden's long bike rides. Before we look at the details, I want to make sure that your paper is correct because there was a typo on some of the papers. This ran as, I think, 5, 10, 15, 20. Make sure it says 0, 1, 2, 3, 4, 5 on your graph. If not, please pause and fix it right now. All right, so this graph represents Weston's trip, and the equation represents Jaden's trip. And the question is, which rider moves at a faster pace? So we first have to figure out how fast they're actually traveling by looking at their rate of change. So again, on Weston's, on the graph, it's really easy to see. We can see it here. At 1, he had went 10. At 2, he had went 20. At 3 hours, he had gone 30. So for every 10 miles, it took him an hour. So again, the rate of change, how far do you have to go up and over? So Weston traveled at 10 miles per 1 hour. That's his rate. For Jaden, it's extremely easy to find the rate in any proportional equation because remember, it's always that coefficient. So the coefficient there says 20, so Jaden was going 20 miles per hour. We could have written Weston's in an equation. We know that his distance was 10 miles per hour, so it would look like that. And then we compare the rates. Jaden is going at a faster rate, so his pace is faster. So the answer would have been Jaden's pace. So what we are going to do, again, to compare proportional relationships, no matter if it is in a table, a graph, or an equation, is to find the rate of change for each and see which one is going faster or slower or is more expensive or less expensive depending on the story. So for our second example, it's a little different. These 3 people are selling bracelets. Janelle's amount is on a table. Rebecca's amount that she sells her bracelets for is on this graph, and Rachel's is in an equation. So again, to find who charges the most or who charges the least, we have to figure out how much they charge, and that's the rate of change. So Rachel's is easy because we know it's just the coefficient. So she is charging, her rate is $3.50 per bracelet. On a table, it is very easy as well, because we just match up. For proportional relationships, we just match up our different pairs. She charges $9 for 3 bracelets, or $18 for 6 bracelets, or $24 for 8 bracelets, or $36 for 12 bracelets, and all of these can be simplified, and I'll write it up here in black, to $3 for 1 bracelet. And Rebecca's on the graph. You can go up 8 for every 2. So she charges $8 for 2 bracelets, or $16 for 4 bracelets, or $24 for 6 bracelets. And so we could write it out like 8 for 2, or 16 for 4, or 24 for 6. All of these reduce to 4 to 1. So she charges $4 per 1 bracelet. Now what that would look like in an equation again is Janelle's amount was $3 for every bracelet. Rebecca's amount was $4 for every bracelet. So we can compare their rates, $3, $4, and $3.50. So who charges the most? Rebecca does, at $4 per bracelet. And who charges the least? So Rebecca was the most. And who charges the least? Janelle, because Janelle, who is buried in the grass right now, only charges $3. So I know this because 3 is less than $3.50, which is less than 4. So Rachel charges the middle, Janelle the least, and Rebecca the most.